Today we're going to talk about a statistical tool that didn't just tweak modern economics, it totally rewired it. This is the story of how one brilliant idea finally gave economists a way to take their most complicated theories about the future and actually test them against cold, hard data. So yeah, let's dive into how one method really did change everything.
And this, right here, was the massive challenge facing economists back in the early 1980s. You see, their theories were getting incredibly sophisticated, trying to capture how we all think about what's coming next. But how in the world do you test a model that hinges on something you can't even see? People's expectations.
Well, the source of this whole headache was a really powerful new idea that had taken over the field, and it led to what I'm calling the rationality roadblock.
Now, this wasn't just some small adjustment. The whole idea behind rational expectations was that people, on average, are pretty clever. They form their ideas about the future in a way that's actually consistent with how the economic model itself says the world works. This made the models feel way more realistic, but oh man, it also made them monumentally harder to work with.
This slide just lays out the difference perfectly. On one side, you've got the older traditional models. They were mostly linear, which just means they assumed these nice, simple cause and effect relationships that were pretty easy to test. But these new rational expectations models, they were a completely different beast. They were nonlinear, packed with all these complex feedback loops and tangled connections that all depended on those invisible expectations about the future. The old statistical tools, they just broke when they tried to handle it.
And that really is the heart of the problem. Just as the source material says, the tools they had simply weren't built for this new world. It was like economists had designed these incredible, high-performance theoretical engines, but had absolutely no way to get them on a test track to see if they actually worked.
But then two economists, Lars Hansen and Kenneth Singleton, came along with a truly elegant insight that sliced right through all that complexity.
And this is it. Their solution was published in this 1982 paper in Econometrica, and it wasn't some minor patch. It was a completely new way of thinking about the whole problem of estimation.
Okay, so this is the whole magic trick. Instead of trying to build a perfect model of the entire impossibly complex world, Hansen and Singleton zeroed in on what they called orthogonality conditions. Look, just think of orthogonality as a fancy statistical way of saying that a model's mistakes should be totally random and unpredictable. If your theory is right, there shouldn't be any pattern to its errors. So their huge idea was, hey, let's just find the settings for our model that make its mistakes as random and as close to zero as possible when we look at the actual data.
And this core prediction has a name. It's called a moment condition. Here's an easy way to think about it. Let's say your theory of archery predicts your perfect shot. Well, a key moment condition from that theory is that, on average, the distance of your arrows from the bullseye should be 0. Sure, you might miss a little to the left, a little to the right, but all those errors should cancel out. Your average error should be nothing.
This core insight was then formalized into a super powerful and flexible toolkit that we now know as the Generalized Method of Moments, or just GMM.
And this really gets to the beautiful philosophy behind GMM. The idea is to just stop getting bogged down trying to model every single little detail of the economy. Instead, you just take your theory's sharpest, most important predictions, its moments, and you just find the parameters that make the model match those specific predictions in the real world. That's it. So how does this actually work in practice? Well, it's a pretty elegant 4-step process. First, you take your economic theory and you pull out its core testable predictions, those moment conditions. Second, you look at real-world data to see what those values actually are. Third, and this is the cool part, you basically tell a computer, hey, find the settings for my model that make the data match the theory's predictions as closely as you possibly can. And finally, and this is so crucial, you run a formal statistical test called the J-test to ask a really simple question. Is the model's best effort actually good enough to be believable?
For anyone who's taken econometrics, a great way to think about GMM is that it's a superpowered version of a classic technique called instrumental variables. But for everyone else, here's the bottom line. It took a known statistical trick for dealing with messy data and basically put it on steroids, making it strong enough to finally handle the complicated world of these new economic models.
All right, so with this powerful new tool in hand, what was the first thing Hansen and Singleton did? They immediately aimed it at one of the most fundamental models in all of finance. And, well, the result was a complete shocker.
So they tested the standard model of the time. This is a big one. It links the way we consume goods and services to the prices of assets like stocks. It's a foundational theory that basically says our willingness to save or spend our money today should show up in how the stock market behaves.
When they ran their GMM test, the results were not good for the theory. This table gives you a simplified version of what they found.
That J-test statistic, the number that tells you how close your moments are to zero, was consistently really high. And in this test, high is bad. It meant the data was pretty much screaming that the model's core predictions were wrong. So the huge takeaway wasn't just that the model failed, it was how it failed. The standard model just could not explain why stock market returns have historically been so much higher than the returns on safer things like bonds. This shocking finding, which was only possible because of GMM, became known as the equity premium puzzle, and it's a puzzle that researchers are still trying to solve to this day.
But the story of GMM definitely doesn't end with just one puzzle. The method itself was so flexible and so powerful that it basically spread like wildfire across every single field of economics.
I mean, just look at this timeline. You can see how this tool just traveled everywhere. It started in finance in the 80s, then it jumped over to help us understand how companies compete in the 90s. From there, it became essential for modern macroeconomics, and today it's even helping us figure out the economic structure of our cities. GMMM and its descendants became this universal language for testing big, complex ideas.
And what's really amazing is its incredible versatility. This wasn't just some niche tool for one specific problem in finance. It became a fundamental part of the curriculum, a standard method in the toolkit of pretty much every empirical economist, no matter what their specialty was. It wasn't just a key for a single door. It was a master key for the whole building.
Ultimately, the legacy of GMM is about so much more than just a clever statistical technique. What it really did was forge a new, much more rigorous connection between the abstract world of economic theory and the messy reality of data.
You see, before GMM, it was often really hard to say for sure if a complex theory was right or wrong. But GMM provided a clear, sharp benchmark. A theory wasn't just an interesting story anymore. It had to generate these specific, testable predictions, these moment conditions that could actually survive a direct confrontation with the data. It truly unlocked a new era of empirical research.
The story of GMM is just this incredible example of how a single new tool, a new method, can unlock decades of research and completely reshape an entire scientific field. It really makes you wonder, what's the next tool out there waiting to be discovered that's going to let us ask the questions we don't even know how to ask yet?